seen static electricity cause a spark of light? What is that spark? What about lightning, the northern lights, or the tail of a comet? All of those things and many others, in fact 99.9% of the universe, are made of plasma. Plasma is a state of matter, drastically different from the more familiar forms. Take ice, for example. Ice, a solid, melts to become water, a liquid, which, when heated, vaporizes into steam, a gas. Continued heating of the steam at a high enough temperature causes the water molecules in it to separate into freely roaming hydrogen and oxygen atoms. With a little more heat, the ionization process occurs, and the negatively charged electrons escape the atoms, leaving behind positively charged ions. This mixture of freely roaming negative and positive charges is plasma, and at a high enough temperature, any gas can be made into one. These freely moving charged particles behave very differently from the particles in other types of matter. When a doorknob, a solid, has static electricity on it, it doesn't look or behave any differently. And with the exception of a compass or other magnetic object, we rarely see matter respond to a magnetic field. But put a plasma in an electric field or magnetic field, and you'll get a very different reaction. Because plasmas are charged, electric fields accelerate them, and magnetic fields steer them in circular orbits. And when the particles within a plasma collide, or are accelerated by electricity or magnetism, light is generated, which is what we see when we look at plasmas like the aurora borealis. Plasmas aren't just beautiful celestial phenomena, though. Imagine a tiny cube made of normal gas with a very high voltage across it. The resulting electric field pushes some of the electrons off the atoms and accelerates them to high speeds, causing the ionization of other atoms. Embedded impurities in the tiny cube of gas cause it to gain and release a precise amount of energy in the form of ultraviolet radiation. Attached to each tiny cube, a fluorescent material glows with a specific color when ultraviolet light at just the right intensity reaches it. Now, make a rectangle out of 1 million of these tiny cubes, each separately controlled by sophisticated electronics. You may be looking at one now. This is called a plasma TV. Plasmas also have implications for healthcare. Plasma chemists create highly specific plasmas that can destroy or alter targeted chemicals, thereby killing pathogenic organisms on food or hospital surfaces. Plasmas are all around us, in forms that are both spectacular and practical. And in the future, plasma could be used to permanently rid landfills of their waste, efficiently remove toxins from our air and water, and provide us with a potentially unlimited supply of renewable, clean energy.